The sum of two numbers is 26 and the product is 133. Find the two numbers. Let's let x equal the first number and y equal the second number. Notice it appears as if the order of the numbers matter, but it really doesn't because we're only looking for the two numbers. From here, we know the sum of the two numbers is 26, which indicates x plus y equals 26. We also know the product is 133, which means x times y equals 133. And now we need to solve the nonlinear system. Let's use the method of substitution. Let's solve the first equation for y, and then we'll perform a substitution for y in the second equation. Solving the first equation for y, we would subtract x on both sides, which gives us the equation y equals 26 minus x. And now we'll substitute 26 minus x for y in the second equation. Performing the substitution, we have the equation x times the quantity 26 minus x equals 133. Notice now we have an equation with just x. Let's begin by clearing the parentheses on the left by distributing x, giving us 26x minus x squared equals 133. Because we have a quadratic equation, we prefer to have the x squared term positive. Let's add x squared to both sides and also subtract 26 on both sides, giving us the equation 0 equals x squared minus 26x plus 133. Let's see if we can solve by factoring. If the right side does factor, it will factor into two binomial factors. The factors of x squared are x and x. Now we want the factors of 133 that add to negative 26. That's not an easy question, but negative 19 times negative 7 does equal positive 133, and negative 19 plus negative 7 equals negative 26, which indicates we have a factor of x minus 19 and a factor of x minus 7. The right side is equal to 0 when x minus 19 equals 0 or x minus 7 equals 0. Solving for x, we have x equals 19 or x equals 7. And now we need to determine what y would be for each of these x values. We can do this using the equation y equals 26 minus x. When x equals 19, notice y is equal to 26 minus 19, which is 7. This indicates one solution is x equals 19 and y equals 7, which is an ordered pair would be 19 comma 7. And now we need to find y when x is 7. When x equals 7, notice y is equal to 26 minus 7, which is equal to 19. So it appears as if we have another solution of x equals 7 and y equals 19, which if we were just solving the system algebraically would be correct. But for the question, we're only looking for the two numbers that have a sum of 26 and a product of 133. For both ordered pairs, notice the two numbers are the same. The two numbers are 7 and 19. So our final answer is the two numbers are 7 and 19. Again, the order doesn't matter, and therefore we actually only have one solution. Before we go, let's check this graphically. Recall to do this, we graph both equations on the coordinate plane and look for the points of intersection. And I've already set this up. Notice we do have 2 points of intersection. One is the ordered pair of 7, 19, and the second point is 19, 7. Both ordered pairs do give us the same two numbers of 7 and 19, which are the two numbers that have a sum of 26 and a product of 133. I hope you found this helpful.